Hey guys, welcome to 2.7. In this lesson, we're going to talk about inverse functions. Now, in a previous lesson, we talked about how you can see if a graph is a function because it passes the vertical line. Well, in this lesson, we're going to talk about the horizontal line test and what it means to be an inverse. Okay, so a couple of things. If you take two functions, call one of them f of x, the other one g of x. If you take g of x, plug it into f, and the answer is x, and then you do the same thing going in the other direction where you take f and plug it in g, and you also get x, those two functions are inverses of one another. Right, and they get x as an answer because any inverse, if you put it on a graph, any inverse is supposed to flip over. So if I have a graph, it's going to flip over this line, y equals x. And that's because, like I said, algebraically, if you plug one function to the other, you should get x both times if they're inverses. And that's because they flip over this x. Now, they could overlap it or whatever, but they're going to pivot along that line. And that's what we're hoping for, and that's what we're going to check. And so, again, if a function passes the horizontal line test that I mentioned a while ago, then we know that that function has an inverse. Not every function does, but if the graph is a function, and then we turn the line test on its side and check the horizontal line test, and that also passes, then the whole thing, it is a function, and if it passes the horizontal line test, it also has an inverse. Okay, and if it passes both tests, then that's said to be a one-to-one function. Okay, so let's look at number one. So I'm going to try that. I'm going to plug g into f and then f into g and see if I can't get an x to show up both times. Okay, so I'm going to find f of g of x. And so that's going to be 5 over 5 over x plus 4 minus 4. Okay, so obviously the 4s are going to cancel out. So that's going to leave me with 5 over 5 over x. And remember that when you divide fractions, it's the same thing as multiplying by the reciprocal. So I'm going to rewrite this as 5 times, and I'm going to flip that fraction, and it's going to be x over 5. The 5s are going to cancel and leave me with x, which is what I was hoping would happen. And again, just because you hope something happens doesn't mean it's going to happen. You just need to check that out. All right, let's go in the other direction. G of f of x. G of f of x. All right, so I'm going to say 5 over x minus 4. Oops, 5 over x minus 4. Plus 4. Okay, so I'm going to have to do that multiplication first. So it's going to be 5 over 5 times x minus 4 over 5 plus 4. Right? That's going to cancel, leaving me with x minus 4 plus 4, which is just x. Okay. That's what I wanted. So it's safe to say that these two are inverses of one another. All right, let's do it again on number 2. All right, on number 2, we're going to, let's see, f of g of x. Okay, it's going to be 7th root of x to the 7th plus 2 minus 2. Okay, so it's going to be 7th root x to the 7th plus 2 minus 2. The 2's are going to fall out. That's going to leave me with the 7th root of x to the 7th, which is just going to be x, which is what I was wanting. All right, so let's do the other direction. So let's see, that's going to be 7th root of x minus 2 to the 7th plus 2. That 7th power is going to get rid of that 7th root, and that's going to be x minus 2 plus 2. The 2's are going to fall out, and I'm going to be left with x, which is what I wanted, which means it's safe to say these are inverses of one another. Now, the other thing that you should know is that sometimes they don't give you two functions. Sometimes they say, hey, go find the function, go find the inverse of this. And so there's a process to do that. Let's go through that now. Okay, so f of x is the same thing as y equals. So I'm going to say y equals 2x plus 5. All right, and then what I'm going to do now is I'm going to switch x and y in the places that they hold. So this is going to be x equals 2y plus 5. And now you just simply solve for y to get it by itself again. All right, so I'm going to subtract 5. That's going to be x minus 5 equals 2y. And that's going to be x minus 5 over 2 equals y. And whether y is on the right or the left doesn't matter. But once you get it to this point, you want to write it in the inverse notation, which is just going to be f to the negative 1 of x equals this function. Okay, and so there's that. Now, because we did this, because we found the inverse, I don't have to check to see if this is going to work. It is going to work. if I plug this into f of x, so if I take the inverse and plug it into f of x, I'm going to get x. And if I do it the other direction and plug the original into the inverse, I'm going to get x. That's just the nature of it. If you do this process, it's going to work. And so this this is my inverse function. Okay. Let's do it again on number 4. So this is going to be y equals 6 over x. I'm going to switch places. This is going to be x equals 6 over y. And now I'm going to multiply y to get it to the other side. So 6. I'm going to divide x to get y by itself. So this is going to be 6 over x. Well, it turns out that my inverse and my original are mirror images of one another. So this is going to be f inverse x 6 over x. So just because I want to show you, let's take this and apply that rule that we did before. So let's do my inverse. Let's take my inverse and plug it into my original. So that's going to be 6 over x. Now if you remember, when you divide fractions, you multiply by the reciprocal. So while this is 6 divided by 6 over x, I can rewrite that as 6 times x over 6. And then you can see real quickly that the x's are going to fall out, and I'm just left with x. Well, it doesn't take a rocket scientist to see that if I go in the other direction and take the original and plug it into the inverse, they're the exact same. So this process is going to work out again. And so these two are inverses of one another, and that checks out. Okay, so that's that. Okay, now, does the function have an inverse? I told you a while ago that we use the vertical line test to see if this is a function, but we use the horizontal line test to see if it has an inverse. Okay, so the same rules apply. I want to know, on the horizontal line test, do I ever hit 2 points on the graph at the same time? The answer is no. So it passes the horizontal line test, and that means this function does have an inverse. Okay, let's try that on 6. Do I ever hit 2 points at the same time? Well, before I answer that, let's remind you, I don't hit 2 points at the same time when I'm looking at the vertical line test. So this is a function. But when I shift over here, yes, it does hit at least 2, in multiple places, it hits 2 points at the same time. All right, and that's not allowed. So this fails the horizontal line test, and so this function does not have an inverse. That's a no. It's a hard no. Okay, number 7. Okay, so I want to find 2 things. I want to find the inverse of this thing, and then I want to find the domain and range of the original and the inverse. Okay, so I'm going to go through the process. It's going to be f of negative, y equals cube root x plus 7. All right, I'm going to switch places. X equals cube root of y plus 7. Subtract the 7. X minus 7 equals the cube root of y. All right, cube both sides, because that's how you get rid of the cube. Okay, and then I don't have to expand that out, but that just means x minus 7 all cubed equals y. Okay, and then I'm going to put this in inverse notation, so my inverse is going to be x minus 7 cubed. Okay, so that's my inverse. For f of x, I want to know the domain, and I want to know the range. All right, so the domain is the set of all x's that the graph touches, and the range is the set of all y's that the graph touches. Okay, so naturally, for any polynomial, it wants to be all real numbers. It wants to be all real numbers. Okay, so I want to look for 2 things, if you remember. All right, I want to look for a fraction, because I can't divide by 0. Or I want to look for a fraction with a variable on the bottom, because I can't divide by 0. And then I want to look for an even root. I can't take an even root of a negative number. I can't take square root of -1. I can't take fourth root of -1, so on and so forth. So as long as I have one of those 2, I'm going to have a problem with my domain, and therefore my range. Okay, again, it naturally wants to be negative infinity to positive infinity, all real numbers. But I'm looking for those 2 scenarios. In this situation, I have a root, but it's not an even root. Okay, so that's not a problem. I can take the cube root of a negative number. I can take the cube root of a positive number. So this is not a problem. So what it wants to be, all real numbers, is what it's going to be. And so that's going to be negative infinity to infinity. Now, this is a poor example because the domain and range don't have any issues. But the idea here is that the domain of the original is the range of the inverse, and vice versa. The range of the original is the domain of the inverse. So these are going to be the same. Okay, so this is pretty much like 5 and 6, or sorry, this is pretty much like 3 and 4, where I didn't have 2 functions. I just was given 1 function and said go find the inverse. So that's essentially what I did here. And because everything worked out with the domain, I know that this works for every version of x. This works for all x. For all x's. Okay. Now, this is easy peasy. This one came from your homework, and I just want to point this out to you. If you remember back to a previous video, we looked at a graph, and it said, when x is this, what is g doing? And then you get an answer. And then you take that answer and you use that to find what f is doing at that x value. You do the same thing here, but you're doing it with a table. So here, you're taking g when g is 8. When g is 8, you get a -2. So this is going to be f inverse of -2. Okay, so when f is -2, you're going to get 6. All right, so that's how you do that. So if this is f of x, if this is f of x, then this is that's the inverse. Remember, a while ago I said that the domain of the original is the range of the inverse, and the range of the original is the domain of the inverse. Okay, so this is exactly what we're doing here. All right, for the inside part, I'm going to look at when x is 8, what is this column? All right, and it's going to be -2. Okay, but because it says f inverse, I'm looking at this column now. When the right column is -2, what is the left column doing? Okay, and that is going to be 6. And so my answer here is going to be 6. That's 2.7. I hope you got something out of it. And if you have any questions, please reach out. And I'll see you in the next video.